Now in this last section, we want to look at how we can use a normal distribution to approximate the Poisson distribution. Now there will be a set of conditions for you to check before you can make the approximation. Now before we look at the set of conditions, let's take a look at this simple application. Now the red histogram that you see here is actually the Poisson probabilities corresponding to lambda equals to 2. Okay, the mean equals to 2. Now if I increase the mean, okay, we can see that the probabilities, alright, get closer and closer to a bell-shaped curve. Okay, now this gives you a good idea why we can use the normal distribution to approximate a Poisson distribution. Alright, now let's look at the conditions. Now let's say I've got x, and x is Poisson with mean lambda. And then of course that means the expectation of x is lambda, the variance of x will be lambda. Now if lambda is large, okay, lambda bigger than 10, okay, and then x will then be approximately a normal distribution with mean lambda and variance lambda. Now note that we also have to use continuity correction here because Poisson is again a discrete random variable. Okay? Now we look at two simple examples to help us illustrate how we can use a normal approximation to Poisson. Now in 19, you have x, and x is Poisson with mean 25. Alright, they want you to use a suitable approximation to find probability of x between 22 and 26. Now how do we do this? Now for Poisson, the only approximation in your syllabus is from a Poisson distribution to a normal distribution, and then the conditions to check are actually just one. Your lambda has to be bigger than 10. Okay, so if that's the case, let's take a look at what we have. We have 25. So we can straight away say, since your lambda is 25 bigger than 10, you can say that your x is a normal distribution with mean 25 and variance 25 approximately. Again, this approximately is critical. Okay, because x is Poisson, it is not normal. So how do we do this question? The next thing I will do is look at this 22 and 26. I need to use continuity correction here because Poisson is discrete. Alright, so 22, if you need to, you can draw a number line. I need to include 23 and not 22. Okay, the first number here is 23 and the last number here is 25. So actually there are only 3 numbers there from 22 to 26. So 22, 23, 24, 25. Okay, so I want everything from 22.5 until 25.5. Everything between these two numbers. Okay, so straight away I can now use my GC, okay, to press out this normal probability and get the answer to be 0.231. Done. Now, in the last example, you have this radioactive disintegration which gives counts that follows a Poisson distribution with mean count per second of 25. Now they want you to find the probability that in 1 second the count is at least 23 and less than 27 by using two methods. A. Use the Poisson distribution. B. Use the normal approximation to the Poisson distribution. So how can we do this? Now, the first thing I will do is to call X, okay, this disintegration. And then if you look at the question, they say that it follows a Poisson distribution with mean per second 25. So every second there are 25 of them. Okay, 25 counts. Then after that, the question wants you to find X to be at least 23 and less than 27. And they want you to find this probability. Now if I want to use the Poisson distribution, then this is easy to find. All you need to do is to change this into probability x less than what? 26, because I don't want to include 27 because this is just a less than sign. Alright, then minus probability x less than equals to what? 22. Okay, so you use the Poisson CDF here and Poisson CDF here, and then you just subtract the two probabilities and you get your answer. Okay, you can see the working proper here. You let x to be the random variable representing the counts of the radioactive disintegration per second. So straight away I write this down. X is Poisson mean 25. Then you use your GC to calculate these two probabilities, take the difference, then you get the answer. Now for part B, I want to use the normal approximation, okay, to find the answer. Alright, I'm looking for this probability. So if you remember, what is the condition for the approximation? Lambda has got to be bigger than 10. Okay, so obviously you can see that here. The lambda is 25. So what I will have to do rather is say, since my lambda is 25 bigger than 10, then I can straight away say that my x is a normal distribution with mean 25 and variance 25 approximately. Okay, and then now this probability is what I want to find. I need to use my continuity correction to change it to x between 22.5 to 26.5, and then use my GC to compute the answer. Okay, it's just a normal CDF from here onwards, and I'll get 0.309. Now note that these two numbers are not the same. The answer in part A is exact. The answer in part B is an approximation. Okay? They don't necessarily need to be the same number. Done.